base for what logarithms are, and your book defines logarithms as log base b of x, and it's defined as the exponent y that makes the equation b to the y equals x true. Okay, now you're all really confused, right?
Yep.
Okay, so this is the thing. Basically, when I think of a logarithm, what I do is I think about an exponent. And how do we undo an exponent? Because this is the thing, when I add, how do I undo addition? You subtract. When I multiply, how do I undo multiplication? Divide. And so when I take the square root of something, how do I undo that? I square it. So now the question is, what happens if I have this in exponential form here? 2 to the 4th equals 16. How do I undo that power? And so we have to have a way to undo the power, and we have that by using a logarithm. So these two things, exponential form, logarithmic form, they're inverse operations. They undo each other. Okay. And so this problem, 2 to the 4th equals 16. How I would write that in logarithmic form? That's log base 2 of 16 equals 4. And so what we're going to do is we're going to talk about how you first of all write in exponential form and write in logarithmic form, and then we're going to solve some equations. So first of all, let's talk about writing this in exponential form. So exponential form means no logarithms. Okay? Exponential form means no logarithms. So from that problem before, it was 2 to the 4th equals 16, and the question is, well, how do I do this here? If you remember what I said that logarithms undo powers, powers undo logarithms. So how I undo this log base 2, okay, is I'm going to put a 2 here and a 2 here. And what ends up happening is that the 2 and the log base 2 cancel, and it leaves me with 8. And that's going to equal 2 to the 3rd power. Now, you're going to have to kind of adjust your thinking and think, okay, that's 2 to the 3rd power. And that's a true statement, because when you think about it, 2 times 2 times 2 is 8. And there you go. That's it. So on this next example, I want to undo the logarithm so that there's no log. And so in this case, it's a log base 4. So whenever I say base, that's the little subscript after log. Log base 4. So what's going to undo that? The 4. Okay? So on the left side, what ends up happening is the 4 and the log 4 cancel. What am I left with? 1 over 256 equals 4 to the negative 4th power. Okay? So you think you can handle that? You see whatever base you've got, and you just raise both sides to that. So now we're going to do the opposite. We're going to write it in logarithmic form. So we're going to write this with a logarithm. So we've written with an exponent. Now what we're going to do is we're going to be given an exponent. We have to write that as a log. What do you think? Were the last ones hard?
I think so.
Okay, so real quick, what I'm going to do, where is the power? It's 15 to the 3rd, right? So basically, I want to get rid of that power. And so to get rid of that power, what I'm going to do is I'm going to take the log base 15 of both sides. Now I didn't have room, otherwise I just would have squeezed it into the left of that 15. And so what ends up happening here is that I have log base 15 of 15, that cancels. What does it leave you with on the left side? 3. So I end up having 3 equals log base 15 of 3375, and that is your logarithmic form. So you have to find whatever the power is. Whatever the power is what you're going to take the logarithm of. So on the next one, okay, I have 125 to the 1/3 equals 5. What do you think you're going to do here? Yep, log base 125, good, of 125 to the 1/3, and that's going to equal log base 125 of 5. So on the left, those cancel. And I've got 1/3. On the right, I've got log base 125 of 5. So far, so good? Any questions? All right, so now we need to evaluate. Now, people sometimes don't like these. I actually like these. These took a while, and I didn't really fully understand these till I got to college, and I learned a little trick. Okay? What you're going to do is you're going to make this an equation. So on every one of these problems, we're going to do equals x. Every one, you're going to make an equation. So now I'm going to undo that log base 16, right? So how do I undo the log and write this in exponential form? 16, very good. So I'm going to do 16 to both sides. So let's cancel. And I get 4 to equal 16 to the x power. Now if you remember, in order to solve that, we need to get the same bases. So I've got 4 and 16. What would be a base that would be the same? 4? Yep. And 16 is 4 squared, right? So really on the left side, this is 4 to the first. So what would be the next thing I could do? Yep, so really I get 4 to the first equals 4 to the 2x. Now what do you know? The what? One equals what? 2x. Right, because remember you can get rid of your 4's because we're just looking at exponents. What does x have to equal then? 1/2. There you go. Okay, log base 16 of 4. So far, so good? Let's look at another one. Log base 3 of 81. So what do you do? Equals x. Very good. Then what do you do? 3. Yep. So on the left, what do you get? Yep. 81 equals 3 to the x. So now I need to think. Can I write 81 as a power of 3? 3 to the 4th. Yep. So what's your answer going to be? 4. Now you really don't need to put x equals 4. You just could put 4 because if you notice in the original problem there wasn't an x. So, and there is another way you can do that. Some of you might be able to do that in your head. Okay, log base 1/2 of 256. So what do I do? Equals x. Good. And then 1/2 on both sides. Yep. So I end up getting 1/2 to the x. Oh, crud. Now I got those stinking fractions in there. Ideas? How else could I write 1/2 so it's not a fraction? Two to the close. Negative 1. Okay, for those of you wondering, remember this is 1/2 to the first. So if I want to move it up, and so then now I need to think, is there a way I can write 256 as a power of 2? So how many 2's give me 256? 2 times 2 times 2 times 2 times 2? 8? Okay. So then what do you get x to equal? Yep. So you end up getting 8 to equal negative 1x. And so then x equals negative 8. Good. So then the last thing we're going to talk about is just what the graphs look like. And all I want you to do is recognize these because when we graph these, we're going to probably use graphing software. Okay, I'm not going to expect you to memorize them. You're going to notice they look real similar to the exponential ones that we looked at. Okay, basically, domain is all positive real numbers. There is an asymptote, and that's the y-axis. Okay, they put f of x-axis, but that's the y-axis. Okay? So anyway, just kind of wanted you to know kind of what those look like, real similar to the exponential ones, and they should because they're inverse operations. Any questions? All right, here's what you need to do. 13 through 36, page 472. We're not going to go on with the new section tomorrow. We'll probably have a worksheet over this short quiz. So anyway.